for the third example, we have our function, the first and the second derivative as well, on one hand. So we have to find the function if it's increasing or decreasing, and which ones are the intervals. We have to find the minimum and maximum, the x and y coordinates. We have to see the concavity of the graph and see the points of inflection. So we're gonna start doing see if the function is increasing or decreasing and which ones are the intervals. So first we have to take the first derivative of the function. We already have that, so you are gonna just write it, and then we have to equal that to 0. So we have to see when which number we have to put on the axis, and that makes our function 0. So 2x equal to 0, and then we have 0 over 2, which means x is gonna be 0, and then because of the denominator is x squared, it doesn't exist because always is gonna be positive. So then that we have our critical number, we're gonna plug that in our number line. We have to do it from minus infinity to infinity, and we put our 0, that is our critical number. Then you have to pick two numbers between those intervals. I'm gonna pick minus 1 and 1, and then you have to use the first derivative to using those numbers. So I'm writing right now the first derivative with minus 1, and we don't care about the number, we care about just the sign. So because the first number is 2 and then the second number is minus 1, that means it's going to be negative, and then the denominator is going to be always positive, which means it's going to be minus. So it's decreasing from the interval from minus infinity to 0. And then we have to do the same thing with the number 1. I just choose that number, but you can choose whatever number you want. Because both numbers are positive and the denominator is positive too, the function is going to be positive, which means it's increasing from 0 to infinity. And then that means we have a minimum at 0, but we need the other point. So to find that point, that is point B, we need to equal that function to 0, because we know that x is equal to 0. So we have to take the first function, which is ln a x squared plus 1. So we have to plug just the 0 on the x, which means it's 0 plus 1, which is just 1, and the log natural it's of that is just 0. That means our minimum point, it's gonna be at 0, 0. So x and y is gonna be 0. I'm just writing right now the points that I already tell you, the minimum, so we have it on the paper. And then we can go to the next point, which is C, find all the intervals upward and downward concavity of the graph. So we have to use the second derivative that we already have, so we just have to write it, and we have to equal that to 0 and find when which number x has to be 0. So the first part is gonna be x squared minus 1. We have to equal that to 0, which means if we plug 1 or minus 1, that is gonna be 0. And because of the denominator it's x squared, it's also gonna be positive as well, so that means doesn't exist. So we have two critical numbers, which are minus 1 and 1. So now we have to do our numerical line from minus infinity to infinity again, and then we have to plug those two numbers on the line and pick whatever number that we want from in each interval. So I'm gonna pick minus 2, 0, and 2. And then we have to take the second derivative again, and we have to replace x, which with those numbers that you choose. In this case, I'm just gonna start with minus 2, and we don't care about the number, so we need just the sign. So because it's x squared on the minus 2, that's gonna be positive, and then the outside is gonna be negative, so that means it's gonna be negative. So the concave is gonna be down from minus infinity to minus 1, and then we have to do it again with 0. That's gonna be positive, because the minus 2 with the minus 1, that means positive, and the denominator is gonna be always positive. The concave is gonna be up from minus 1 to 1, and then the last one is gonna be 2. I plug the number 2 on the x's, and that is gonna be negative again, because minus 2, well, it's negative, 2 it's positive, and then the other one it's negative. So that means the concave is gonna be down from 1 to infinity. So that means that we have 2 points of inflection, -1 and 1, as you can see on the graph, because those ones are the changes from up to down. And yeah, so that's the point C. So we have the point D. We need to find the X and Y coordinates if any points of inflection. So we have those 2 points of inflection that we had from the graph, which are -1 and 1. And then we have to just plug those numbers on the first equation that they gave us, so the function. I'm doing that right now, and that is ln 1 plus 1 is gonna be 2, and then the other one, because it's the x squared, that's positive, and then the other one is gonna be the same because 1 is positive. So the points are -1 and ln 2, and then the other one is gonna be 1 and ln 2, as you can see on the paper.